Today we have here with us Mr. Ashish Arora, EVP, Nextra Business Head, Bharti Airtel, Mr. Vikram Anand, Infinera, VP Sales South Asia, Mr. Vito Di Maria, Nokia Vice President, APAC Optical Networks Business Center, Mr. Prakash Shetty, Red Hat Senior Director Enterprise, Mr. Drew Martin, Huber and Sohanet, VP Market Management, DC Fan Communications Strategy and Business Development. And last but not the least, we have Mr. Abhishek Tiwari, who's our partner and moderator for the session in KPMG India. He's the Program Director, G and PS Economic Growth. Thank you, sir. Over to you for your session. We also have Mr. Sudarshan from Pure Storage, Head of Systems Engineering as well, sir. Please.
A very good evening to all of you. I know this is the last session of the day, so therefore I think people might be tired, but we'll try to keep it as much alive as possible. At the outset, I would like to thank IMC for arranging this fantastic panel of experts for this discussion on data center. I think the entire industry is pretty much sitting here. You see telecommunication, data center operator, you see fiber connectivity, data center interconnect, manufacturers, everything. So, and it is my privilege to share the stage with such an industry stalwarts. There is a number, there is a key metric which goes around in the industry, which says that India is generating 20% of world's data, but is keeping only 2% of it, which means 18% of the data generated by India alone, we are unable to keep it within the national boundaries, and it goes outside. That says something about the industry potential in India. The second example which I would like to quote is when, so I was instrumental in writing Government of UP's first data center policy. It was way back in 2020. And when we were writing the policy, we were it was very difficult for us to put up a target in the policy that what are we chasing. And when we looked at the number in terms of megawatt, India then had the overall megawatt capacity around 375. So for us, it was difficult. How much should we keep it? 150 megawatt, 200 megawatt. Finally, we kept it 250 megawatt. That was ambitious, that we will chase this number in 5 years. And to our surprise, we closed 675 megawatt in just 1 year of the notification of the policy. Just 1 year. As of today, as we speak, it's been around 2-3 years. The total number of MOUs which we have signed are worth $15 billion, and total megawatt capacity which we are going to commission in the state of Uttar Pradesh, primarily in Greater Noida region, is around 1200 megawatt. And I'm telling you this story only from the UP's perspective. So you can understand what is going around in this country in the data center industry. So now I will start. I think Ashish is not here with us. So I will start with Vikram from Infinera. So Vikram, what impact does subsea cable connectivity have on India's global data center ambitions?
The connectivity portion, right? You just mentioned that a bulk of the data that India is handling today is actually, being sent out, right? So actually it needs to be the other way around, right? We need to, the kind of, infrastructure, the low cost of setup that we have in India, we can actually, and now we are, even getting power surplus in many states, right? So we can actually create in-house data centers and start catering to workloads from outside, right? So anyways, I think what's very critical is the subsea connectivity, right, is to give a global infrastructure, when you're looking at it from a single data center standpoint, right? Especially when an enterprise is looking at consolidating its various workloads, subsea connectivity becomes very critical. But it's not just subsea. What's happening today is that there is a center of gravity, data gravity that is being created with these data centers which are spread across various locations. So earlier you saw data centers only coming up in Mumbai and Chennai where the subsea ports were, subsea landing stations were. And you just mentioned you did 1.5 gigawatt worth of MOUs in UP, right? Now that will require a lot of terrestrial connectivity, which will be, be required to connect not just the subsea landing points, but also these terrestrial data centers. And that's the, the overall play. Apart from that, these data centers, which are center of gravities today and spread across various locations with the intent of being closer to the customer, are, actually attracting other data sets, and that's the gravitational pull that they talk about, right? The data gravity. And these need to be interconnected to each other, and that's where data center interconnectivity plays a very important role. So to your point, it's not just subsea, it's terrestrial and also DC, the data center interconnect from a metro standpoint, which becomes very critical for managing these data center workloads. Apart from that, the capacity that you are talking about right now, I think is just catering to standard workloads, right? You also have to consider the AI, the generative AI workloads and the impact that will have from an interconnectivity standpoint. So to summarize, I think, you will need to look at connectivity from a holistic purpose, not just from a subsea standpoint, but also the terrestrial long distance and also the metro DCI, which would be, which would play a very significant role as data centers scale up to manage AI workloads.
Thank you, Vikram. Moving on to Vito. So Vito, thank you so much for joining us. He's coming all the way from Singapore. Now, looking at the Asia Pacific strategy of Nokia, how do you see this entire strategy aligns with India's data center market, the way it is emerging? And how do you find India's market important and significant for your growth as such?
Yeah, Abhishek, first of all, thank you for having me here. It's always refreshing to be in India, to see what's happening here. I read there, the future is now. I would have added the future is here as a suggestion for next year. No, look, this morning we've been hearing, Prime Minister Modi, but also all the other speakers talking about the journey of India in terms of, reaching the unconnected, right? And, the journey of India in terms of digitalization, the journey of India in terms of startups that are being basically created in this country. So all this is going into one direction, which is more and massive data, generation, right? Data generation, data consumption. Now, you look at also from a geographical perspective. India is sitting in a very strategic point. It actually can become the bridge of connectivity of the East and the West. You look at, unfortunately, the geopolitics situation and what's happening, and how it's difficult to become, it's becoming difficult to lay down cables in certain routes. Then you see the emerging of, alternative routes to again create those global connectivity that, the world is requiring. So India is basically, playing a central role in that as well. When you look at it from the APAC perspective, right? I think my colleague here, was mentioning the point of, the data center and, the new data center and the implication of artificial intelligence. I would also bring it to another, I would also bring another perspective. If you look at the statistics from United Nations, basically, more than half of the, young population, it's basically sitting in Asia, right? You look at the consumptions of, applications. You look at the, how much times people spend on, social applications, how many different social applications are used per people. You see all these KPIs, the countries that rank at the top are basically in Asia, right? So that means that the majority of those investments will come here. And then you bring artificial intelligence. I think artificial intelligence, we are just at the beginning to understand what are the implications in terms of, building data center and connecting data center. We were, if you look at data center, we went through the area when players wanted to bring data center as close as possible to consumers. Then you started having problems with power. Then you wanted to bring basically data center to as close as possible to the power sources. Now you add the artificial intelligence variable, which basically says that you cannot have all the workload in one single data center. You basically need to distribute those data centers. So the patterns of traffic will be completely different. You will have, as always, you have high capacity, but now you're going to talk about burst, and you're going to talk about symmetrical high capacity. That's why at Nokia we talk about scale made simple, because yes, we can talk about beautiful chipset generation, we can talk about the highest speed you want, but at the end of the day, you need to have that elasticity to basically provide this connectivity, this unpredictable connectivity that AI will basically bring.
Thank you so much, Vito. Moving on to Prakash from Red Hat. Prakash, any discussions around the data center industry is never complete without talking about the open source technology. So how do you see open source technologies not just impacting on the data center industry as a whole, but also transforming the way that the industry is functioning today? So your point on this.
Sure. Thanks, Abhishek. Thanks, Abhishek and IMC, and thanks, fellow colleagues and panelists here. I think I would start with like what Vito said. The future is open. Future is now. In fact, it actually somehow relates to our theme, which is the future is open. We always say it's open, and it's open because the way we sell the software to the world. So if you see today, telcos are putting more and more faith on the scale, skills, and capability of hyperscalers to run their mission-critical functionality on the cloud. And today there's no cloud. I mean, I can safely say that there's no cloud or a data center which does not run open source technology, and for that matter, Red Hat. And that's because the power of open source has reached every nook and corner of the customer and their data centers. If you see, open source software provides the flexibility to have customizable software which caters to the needs and demands of telcos. Today, telcos want to rapidly innovate and move much faster than their competitor. I think that open source is the way to standardize a lot of their systems in the organization, a lot of uniformity that they can bring to the table rather than keeping it a closed source software. And that's where we are an integral part of any data center or any cloud provider. And that's one of the reasons why telcos very efficiently can move towards any hyperscaler. With the advent of 5G and AI and other technologies, the demand for data is so high that the internal data centers or enterprise data centers cannot cater to these kind of demands. The only way to look at is moving towards the hyperscalers. Maybe not necessarily 10% or 100% on a hyperscaler, but looking at a hybrid or a multi-cloud strategy, because that's the best way to look at, because choose a software that can run on any platform, whether it is bare metal, virtual, or a hybrid or a multi-cloud kind of thing. And Red Hat is a best fit in this kind of a situation where it offers an open source solution which can run on your on-premise data center, can run on the cloud, and that's why most of the telcos have built their private cloud on Red Hat technologies, whether it is OpenStack or OpenShift, but they have extended the same to the hyperscaler. And that's the story, and we see at full pace, and we are both the telcos, hyperscalers, and Red Hat will capitalize on that. Thank you.
Thank you so much, Prakash. Moving on to Drew. In terms of the high-speed connectivity, and data centers are now emerging across different parts of the country. They are not anymore focused in only the metro cities. So if you look at the high-speed connectivity and also the data center interconnection, how do you emphasize the importance of data center interconnect as well as the high-speed connectivity for the growth of the industry overall and the democratization of the data center industry?
Well, it's an interesting question, and thanks. I'll extend my thanks for being here. From my point of view, most of the work that we see that we do with the hyperscalers today is really looking at their internal networks. Actually, it's the biggest rush that we're seeing with those guys is their need to upgrade their internal infrastructure and their internal networks to cater for the excessive demands that AI and these other technologies are bringing and the throughput they need inside their networks. So there's a real rush to actually come up with new architectures within the data center, particularly in their back-end inference networks, which is where they're kind of deploying GPUs and clustering those together. And that's where they need this massive throughput, really large scale, resilience of networks, and that's where those things are most urgent. These kind of new networks that they're looking to build are kind of going away from their traditional technologies where, if you think about a data center network itself, it hasn't really changed much in many, many years. And this new redesign is needing new architectures that are particularly based around photonic networks with high-speed interconnect that gives you very, very low latency. I mean, a key factor for AI is that the need to have low latency, and traditional CLO infrastructures just really don't allow them to scale to do that. So what we're seeing is a real push on new technologies such as optical circuit switching, which is kind of an agnostic technology that gives them a real heterogeneous approach to the networks. They're seeing different data rates through the networks, and using traditional packet-based switches at every level through their network just causes bottlenecks and throttles the network. So we're seeing a huge investment in changing the way that they design their networks, both predominantly in the back end, but even in some of their front end networks. And it was interesting, it was mentioned earlier on that you have to not only spread those workloads within the data center, but outside of data centers and between them as well. So that's putting huge demand on the data center interconnect and the latency within there, but also meaning those front end networks are extending across multiple different locations as well. So there's lots and lots of pressures, and we're seeing a real push to change in some of the away from some of those traditional spine leaf architectures to more innovative architectures that allow better throughput. But also the key thing there is it saves them a lot of money. If you're not doing OE conversions at every layer within the network and you're doing everything on the optical domain, you're reducing one whole layer of conversion and transponders or transceivers. So the power consumption of those networks is really reduced as well. And that's a key thing as well. I mean, one of the hyperscalers recently went and published that, by changing out one layer of spine switching within their network to circuit-based switching, saved them 40% on power consumption alone. And those things are huge. Not only does those technologies allow them to work around failures in the networks because you've got more nodes connected, but you're also saving money as well. And that's a key factor on many a talk we talk about today.
Thank you so much. Vikram, would you like to add something on the data center interconnect side?
Yeah, actually, so Martin brought out a very good point, right? See, one of the important metrics that, data center providers, especially those who are in the, infrastructure as a service or as application as a service, right? What matters to them is the PUE, right? Which is the power user effectiveness. And that, so they would like to minimize, ideally it should be one, it's never one. We don't live in an ideal world, right? But if you see the latest requirement even from the government, Mission AI is 1.35, right? Now, how do they really get there? Cooling costs. So PUE is essentially what your cooling costs plus your network costs plus your other infrastructure costs and your, workload costs, right? Over the workload costs. Now, your cooling costs aren't going to go anywhere in India because of the ambient temperatures, etc., that we have. Of course, there's innovation happening around cooling, but the network costs is something which, if you can optimize to the point what Martin was making, I think that's very critical. And that's where, I would like to highlight is where we have a clear differentiation when it comes to data center interconnectivity. because of the technology that we offer, right? Infinera offers from a Super C, Super L band, and the overall power per GB reduces, right, significantly, and that has a direct impact on the PUE, right? So I think DCI plays a very critical role, and especially in an environment like India, where you will need a lot of network connectivity to happen. I think the power factor would be very critical that the data center providers and hyperscalers would need to consider when it comes to DCI and building of data centers.
Thank you, Vikram. So, Darshan ji, my next question is around the hyperscalers. The title also says hyperscalers and data centers. And this question I would like to ask on behalf of the common people. Because hyperscaler is a term which is doing the rounds in the industry, but not many people really understand the difference between a regular data center and a hyperscaler. So if you could decode this hyperscaler word, and what are the significant considerations which go into developing a hyperscaler, data center?
Sure. Thanks for that, Abhishek, and a warm welcome to everyone. We've seen the evolving landscape, right? I mean, when I talk more and more to a lot of business and customers and etc., the concept of data center is actually diluted because data now is spread across. It's just not, what is the word? I mean, let's first decode the word data center, right? Traditionally, you had the concept called data center, where you had a center where all the data was located. Now we are talking about borderless data center, which is not only within the country, but across the world. We are moving into a more multi-cloud kind of approach. We're talking about edge, we're talking about captive data centers, we're talking about using hyperscalers and etc., right? Hyperscalers, as you know, the big 5 hyperscalers, the popular ones like the Azure, AWS, Google's and etc. Massive infrastructure, and as well as the captive, hyperscalers that are there in the country. Massive infrastructure that is deployed, purpose-built data centers out there. They're not only providing infrastructure as a service, but they're offering various other services, and the evolving landscape that has changed from a workload standpoint. Right now, we're talking more about AI, Gen AI, and all of those, right? So the point really is that, what is the critical difference between data center and a hyperscaler? There's a lot of difference across the element, the components, and etc. But I want to dwell upon from where I come, where I'm a practitioner, which is around the data stuff, and more about the data infrastructure that is used, that is there. What we see is, first and foremost, we all are in agreement that because of the digitization that has taken place. I'm here at IMC just about a few months back. I was at the Global FinTech Festival where, there was a lot. So it's just an evolving landscape of digital landscape that's happening right across the banking, finance, telcos, every vertical. Every business now is an information exchange that's happening across different parties out there. And there's an explosion of information, and data is the new oil. So data infrastructure becomes a crucial element. Now, when you're putting this within a data center or adopting it in a hyperscaler, or hyperscaler is looking at, laying out this massive plumbing for data acquisition, data storage, data retrieval, as well as data processing, and getting inference from it. The crucial elements that go in all of this is, one, like everyone is discussing here, is the high-speed network connectivity that you have for the data ingestion that could happen across multiple sources. Once you have that, how are you ensuring security of the data, governance, compliance, security, and more now you have things like ransomware as a service, cyber attacks. It's, there's millions and millions of dollars of assets sitting behind, whether in the hyperscaler or the data center. How do you protect the data that is there, right? And once you're also looking at the life cycle. It becomes painful and it becomes exceptionally nightmarish to kind of think about repeat runs of the infrastructure migration and etc., because the infrastructure is aged. Is there a scenario, is there technologies that have kept a pace where you can do non-disruptive migrations, don't have to worry about massive lift and shift of the data that's happening, because you're not talking about terabytes, we're talking in scales of exabytes out here. So what I would say is the concern when it comes to data, be it a hyperscaler or an on-prem data center, remains intact, which is essentially, once I get the data in, how do I protect, how do I secure, how do I manage? Manage becomes an important thing. And how do I constantly upgrade myself without having to go through a painful lift and shift process? That's about it. With the hyperscalers, you're talking about mega scales in data centers today. The scales have vastly improved even with captive data centers, but the concerns remain the same with the data infrastructure. And that's where, vendors like us come in and elevate all of these concerns that I'm talking about. Yeah.
Thank you so much. So, considering Ashish was unable to join us, so obviously the telecommunication part is not being covered. So, this is an open question to all of you. You may feel like answering. Uh, you know, uh, we all are talking about the 5G deployment across the country, and obviously 5G has a certain play in the data center industry. So, how do you look at the 5G's rapid deployment across the country in terms of having its impact across the value chain, starting from hyperscalers to even micro edge data centers? So, what is your view on that from 5G perspective? Anyone feel free to join. Open question.
I think first of all, the whole point of so far we've been discussing about what's going inside the data center and what are the requirements of the data centers, the data that is coming. What we've been missing in the discussion is basically how do we reach the consumers, how do we reach the enterprises, how do we reach the people that are basically, or the functions that are using this connectivity. And this is where 5G comes into play, right? Which is how you can deliver those premium connectivity, right, to whether they are the people or the enterprises that they are then using those workloads that are inferenced into the data center. So clearly, the role of 5G, it's essential as an enablement of digitalization. I think when it comes of, for example, our perspective, which is to provide connectivity, and when we think about that into India, right, where you have, certain condition in terms of, for example, number of fiber cut every day, right? So you have to think about the technology that enable not only what I said before, the scale and the scale made simple, but also you need to think about the resiliency, right? We are thinking now about technologies that are going to enable applications for, healthcare, for example. We're talking about, actually I was meeting recently one of the biggest hyperscaler, one of the key leaders in the region. He was talking about not even more resiliency, he was talking about availability, right? So the infrastructure that is powering those applications needs to be basically providing availability. And I think, if you do not engineer your product, I'm talking about the product that deliver connectivity. I'm sure that the colleagues will talk about their other part. If you don't engineer and design the product, thinking in mind that yes, you need to have power consumption, yes, you need to have yes, you need to have capacity scale, but you also need to provide availability and resiliency. That is, very important. And I think you were mentioning about the security. With 5G, with AI, with the fact that we are in fact multiplying by a big scale the number of endpoints, the risk on cyber attack is basically multiplied by it's scaling by a 10 factor, 100 factor, 1,000 factor, right? So you need to think about built-in security. So for example, we start talking about quantum safe networking. What does it mean? We need to be ready today for the moment when quantum computing will be available. Today, data can be, there is no storage problem, right? So today you can get data, put it there. When your quantum computing technology is available, then you crack it, right? So you need to have those, safety mechanisms that allow to be quantum safe right now. And that's why we also talk about quantum safe networking. That's why we talk about quantum safe networking, for example, at the photonic layer, right?
Anyone else? Yeah, please.
Yeah, I think you can look at this lots of ways, and I totally agree with what you said, but it's all about convergence for me. At the end of the day, 5G, be it Internet of Things, be it AI, it's all about data, and it's creating more data and being able to store that data and process the data. And as you said, that's about connecting everything together with a very stable, very high bandwidth network that's also low latency. I mean, at the end of the day, what 5G is also driving, and whatever 6G might be, that when it comes down the pipe, is that you need to have a very low latency connection to actually be able to talk and everything to run real time and work properly. And then you bring quantum on top of that, that this is about putting quantum over the top of existing networks. It's about pushing bandwidth that you can put ultimately over photonic networks at its absolute maximum. You know, there's lots of things that are happening that to drive that. I mean, one of the big hyperscalers has just put a huge investment in hollow core fiber recently. You know, it's all about latency and reducing that connectivity time. You know, the reason that edge data centers are being talked about is to bring data close to, and applications close to the user to reduce latency in those connections. So everything's driving to doing more quicker over existing networks, and there's lots of things to do that. And I think there's, you know, we're going to see a whole proliferation of technology to drive it, but it's just making all of our jobs a lot harder, because it's about doing more with what we've got, the infrastructure we've got, or pushing the infrastructure we've got to do more for us, because we need to do more and more storage, you know, more data a lot quicker.
Thank you so much. Moving on, Vikram, there is, in fact, this is one question which impacts all of us, which is climate change and sustainability. And considering the data center industry, you know, it is called power guzzler. There's huge amount of energy consumption, the water resource requirement. So how do we tackle these concerns, and how does the data center industry grow and mature itself that these concerns are up to an extent alleviated, if not completely minimized?
So I think, you know, the data center players are, you know, very sustainability conscious, if you will, right? I think focus around green power is already going in, using renewable energy sources. And, you know, I'm sure in the MOUs that you mentioned also, there must be some clause around, you know, how do you really focus on utilizing renewable energy sources for the green power, right? So that's the first part. The second part is what I already talked about earlier, right? How do you really focus on more innovative cooling methods so that you can reduce, you know, the other lateral costs, which are not really revenue generating costs, right? So I think that is a key focus that you'll see a lot of, you know, OEM players, network players, as well as data center players, along with the hyperscalers focusing on. Liquid cooling is turning out to be something which is, you know, folks are focusing on. So you'll see that evolving over time, going back to the sustainability goals that, you know, the entire ecosystem has signed up to.
Sure, thank you. Anybody else want to expand upon it? Because this is a topic which concerns all of us.
So statistically speaking, I mean, world over, the data center typically takes about 3 to 4% of the entire power consumption. I mean, out of that, from a practitioner's view, 20 to 25% actually gets guzzled up by the storage infrastructure that's there within the data center. Now, when we talk about sustainability, it's just not about power and cooling. Obviously, what we are looking at is you're looking at bleeding cutting edge technologies that is able to give you densification, right? So because we all accept that the storage is exponentially growing, you know, because of rapid digitization, new workloads that are coming in and all of those kind of stuff. So how do you densify? And densify not only in the compute side, but also on the storage side. Because at the end of the day, you need compute, you need storage to store the information and the data that is there. So densification is absolutely important. And when you densify, the best media is not going to be your hard disk drive, because hard disk drives are guzzlers of you know, power requirements. It's typically the flash technology that comes in. But when flash comes in, there's also the concern of cost associated with it. So you're looking at technologies that is, one, able to densify almost about 10 times of what is available today as a normal you know, capacity. At the same time, you're looking at a total cost of ownership that pays over by investing in such technologies that is there. That is essentially on the power and cooling, but also the aspect of sustainability comes in is the reusability of the entire. We're talking about e-waste generation, right? Because if you're going to be deploying exabytes and exabytes of infrastructure, be it on hyperscaler or your own data center, 5 years down the line, you're going to be junking it in terms of e-waste. That's a huge amount of e-waste generation. So is there technologies, is there commercial model available that helps you reuse majority of these components and constantly upgrade your infrastructure such that they become better over a period of time? Those are the areas that we look at from an overall sustainability standpoint and more from the storage standpoint, and there are answers to that. Yes.
Sure. Thank you so much. Vito, this is a question from you. Global telecom, being a global telecom equipment provider, how do you see the equipment manufacturing in data center industry evolving, and what do next 5 to 10 years look like in terms of advancement of the infrastructure equipments which we are using currently in data center industry?
Yeah, that is a great question. I think, Abhishek, many of the topics, somehow we've touched. Let me start. For example, from the story from the PowerPoint, right? Not the PowerPoint, the presentations, but the PowerPoint. Jokes aside, look, we've been investing, significantly amount of R&D budgets in trying to deliver and address the capacity problem. That was basically the first thing that came when we started talking about the center interconnect. With that then came, the problem, and I was hearing before Mr. Dushmanta, for example, from Vodafone Idea, that he was talking about the role of the CSPs into this ecosystem, right? So they were the first one, building networks that were consumed by, OTTs and others. And therefore, the cost per bit problem came into the picture. Now we are reaching, actually the limit of the physics. Many of you may remember, with academic background, may remember about the Shannon limits, for example, right? So we are reaching what people predicted and mathematically proved are the limit of, the physical limit of the communication channels. So now, whatever we do in terms of investment into, silicon technologies, will not bring any more, disruptive innovation in those two areas, maybe incremental, but where we can see, the real contribution will be in power per bit and will be, I think, in densification, right? So we will do more, a little bit more, maybe with a little bit less cost, but in much, much, much less space and with, requiring much, much less power. This is, in my opinion, the first major trend that we will see in the next years.
Thank you so much, Vito. Moving to Prakash. Prakash, if we look at the platforms and applications market as a sub-segment of the industry, this is a segment which we tend to ignore a little. And but this is very important for the industry. So how do you see this particular segment emerging within the data center industry and contributing to a large extent? Because if I talk about it from my personal experiences, when we were chasing the investment in under the DC policy for government of UP, this is a segment which we also ignored, very conveniently, and pretty much we were going after the hyperscalers where the big ticket items were there. But we understand that this segment or sub-segment is extremely crucial for the growth of the industry. So how do you see this?
I think if you see the advent of hyperscalers or large-scale enterprise data center, they're actually reshaping how telcos are looking at IT infrastructure and their own internal data centers. Because the way the hyperscalers or any other data centers, some of the local data centers that we or cloud providers that we talk about, the kind of flexibility and the agility they bring to the table, it is actually forcing the telco providers to reevaluate and rethink their IT infrastructure strategy of moving from a capex heavy to an opex environment. Because and this also facilitates the telcos to look at invest on cloud technologies. Plus, multi-cloud, hybrid cloud is something that is the need of the hour. Hybrid cloud further, if you see the hybrid cloud story, it further accelerates the deployment of AI, machine learning, or data analytics story, because that helps these telcos to provide a better customer service, operational efficiency, you know, helping them cut over their competition. It doesn't limit there; it extends to the edge computing as well. As more and more 5G proliferates in the country, the demand for edge computing grows for supporting low latency application or IoT devices. All of these is possible, you know, if the hyperscalers provide a distributed computing where they would rather provide computing closer to the end user or edge solutions rather than in the data centers, which previously wasn't possible at all. I think again, this overall, the advent of hyperscalers or large data centers outside of the customer data center helps all the telco providers to do better in terms of operational efficiency, service delivery, as well as, you know, thinking ahead of the competition.
Thank you so much, Prakash. Drew, if you look at the AI, you know, with the advent of AI and ChatGPT, now the data workload has been increasing consistently. So from the hyperscalers point of view, and if we dig little deeper, how do you see these hyperscalers are managing the network architecture to manage the workload which has been caused upon by the artificial intelligence?
Yeah, so I mean, I think honestly, I probably covered a little bit of that in the first bit, you know, how they're looking at their back-end networks and kind of re-architecting some of those things there as well. And the other thing that we're seeing that kind of really helps that efficiency, particularly when it comes to AI deployments, is you know, so many of the hyperscalers are all looking at kind of disaggregated networks as well. So then, you know, this is about how they can increase the efficiency of their data centers by connecting together all of their building blocks with a photonic backplane. So what it means is instead of deploying, you know, your data centers on structured servers where you've got a certain amount of compute, be it CPU or GPU and storage, etc. And if you need to deploy models on that server, if you haven't got the right part, you have to go to the next available one. It's very inefficient. So, you know, lots of the guys are looking at creating these sort of new disaggregated functions that connect everything together so that you can actually create virtual machines, which means that those AI deployments can call up the right amount of GPU, the right amount of CPU, the right amount of memory to run that particular workload, run it, and then tear it down again, and then connect it back up again for the next job and create the right kind of virtual machine each time. So again, it's really about doing more with what you've got, and then a bit of re-architecturing in your back-end networks to kind of suit, you know, the new generation of networks that are required for large learning models, you know, so where you're connecting together GPUs in Taurus or Dragonfly networks, which are much more efficient than traditional DC infrastructures. So, yeah, various different things that we're seeing them do there.
Thank you so much, Stu. Sudarshan, what is the future of data storage, app modernization, innovation is looking like for you in next 5 to 10 years within the industry? How do we see the industry evolving around these aspects?
Yeah, thanks. I think covered some of it in the, you know,
From the pure storage perspective.
I'll just borrow from all the answers that's been given by all the panelists here, right? If you really look, what is the future of storage, and especially from pure storage standpoint, right? The first and foremost thing that we want to solve is exactly to that problem that Drew was mentioning, is essentially you need a lot of automation, API-centric world right now. What I mean by that is a lot of, obscuring the underlying, under the hood, protocols, platforms, technologies, and all of that. And you want to move into a consumer-based, usage-based approach. It's not only a technical shift, but also a commercial model shift, where you're paying for what you use, and what you use is completely automated, self-driven, self-healing kind of storage systems that are in place. Based upon the workloads that you want to run. If you're running databases, you're looking at traditional protocols out there, system of records typically. But if you're looking at modern workloads like artificial intelligence, machine learning, and all of those, you're looking at generating large amounts of unstructured data that have a different set of tenants, different set of protocols of access, and etc. But as an end user, as a consumer, as a data consumer, you would want the vendor to mask all of these complexities and provide an easy way to consume, and that in my view is going to be an API centric approach with a lot of automation. We are talking right now about conversational AI in the storage platforms. Like I'm sure everyone here has used Gemini or Chat GPT and etc. And that's been a phenomenal game changer in the humankind in terms of, for the digital humankind in terms of the conversational AI. So you want your systems to also be, you want to have conversations with your systems to kind of check the health of the system, check the security parameters, check about forecasting, consumption, all of those. So we're bringing in a lot of conversational AI ops into these platforms, automating them, making it simple for the users to use, bringing that conversational AI. But where we're really solving for our customers is the densification, which I call. Right now, the industry standard, just to give you a perspective, industry standard, flash media is roughly about 30 terabytes, okay? We are talking about, we've already launched the 75, we're talking about 150 very soon, and we've publicly announced about 300 terabyte in the coming year. So a single flash drive is about 300 terabyte. And when you put it in a system, you're talking about petabytes and petabytes in a single rack. So which means that you're able to walk up to traditional data centers and collapse, like what the virtualization did to the world of bare metals, is to kind of collapse that and have that virtualization first approach, which meant that you completely revamped how power consumption, cooling, your workload efficiencies, TCOs, everything goes up. We're doing the same with the storage industry by densification. By densification on flash, not on hard disk drive. We're giving the performance, we're talking about low latencies, we're also talking about storing huge amounts of data, and true to the adage that data is the new oil, right? So you store massive amounts of data in the hope that you're able to retrieve useful information, which can become a new revenue stream for the businesses later. So, like I said, platform obfuscation, simplicity, API centric, densification of the storage is where we are driving that. And that not only within the data center, but we are also able to do that in the hyperscaler environments as well. Yeah.
Thank you so much. So the last question to the panel, and this is an open question to all of you. How do we see, and this is a myth to bust, because if you look at the data center industry, largely it has been tagged as a capital intensive industry. And especially talking about from the government's perspective, when we were looking at the policy, I was of view that there has to be some play for the startups in terms of coming up with new age innovation. But I found it very difficult to convince a lot of people, because they were saying, what will startups do in this, capital intensive industry? The only thing which startup does not have is the capital. So what is your thought? And I personally pursued to have a clause wherein we proposed a center of excellence to be built up under the policy where we will be promoting the startups. But to my surprise and also a little, sad affairs, that so far I haven't come across a decent startup which can claim to do something worthwhile in data center, whether, any kind of innovation. So what is your thought? Do we really have a space for startups in this space? And if there are those top 4-5 things wherein startups could come in and could think of evaluating to do some sort of innovation which is not so capital intensive, and they could decently go to the government for grants and look at investors to seek few crore rupees to do something worthwhile, is there a space? Can we expect startups to do something, or is it a completely no-go zone for them? Anyone?
Maybe I'll take a stab on this one, because while, of course, in the data center space, you said that startups probably are not prevalent, but I think there's also another thought. While there's a need for hyperscalers. There is also a constant talk and thought that we need to have a sovereign cloud. With the geopolitical situation that's prevalent and all the challenges, it is also good to have an option of a sovereign cloud. And government is, I mean, I wouldn't say a pure sovereign cloud, but government has, some of the departments within the government have floated RFPs for creating a cloud-like environment or a data center for their captive consumption of government, and where there are Indian players who have formed consortium or have partnerships with some of the startups, because when you say data center, it's not about the brick and mortar infrastructure that we're talking about. There's a lot of software that goes into a data center to make it a cloud-like environment. And a lot of cloud management capabilities that I believe there are enough startups who work around this area. And that's one area that I surely can look at. We coming purely from an open source company and purely believe so. I mean, we still believe we are a startup. We're nimble enough. And I think that there are enough and more startups working around in this field. And this is probably an opportunity for some of these startups to collaborate with data center providers or companies who build data center, who can provide data center, who have the capex required, and the collaboration can happen. That's a thought that comes to my mind, and I thought it's something that I wanted to share.
Sure. Anyone else?
If I can just
Yes.
add, right? See, I think Prakash made a very brilliant point about the sovereign cloud. I think the sovereign cloud is a journey, right? It's not just going to happen with a click of a button. And if you see the government incentives, what's happening is in this Mission AI, the changes in the recent RFP, right? I think they're making the environment more conducive for small, medium enterprises to also go in and bid, And, the other thing is the ecosystem that Prakash talked about, right? I think it's quite important. Like, for example, I don't want to name, but there is a startup which started operations about 4 years back. And today they are the leader in GPU ordering, right? And, they are getting even support from the GPU vendor and the government. So I think, you will obviously need more and there is a lot of space, a lot of opportunity which is available for more such startups to come up. You will definitely need, some investor backing, like they had a backing of a large construction house. I'm sure, there would be other big industry houses, and there are other big industry houses who want to get into this space. It's just that, I think it's just the meeting for these, the inflection point where these startups meet with these investors and these business ideas come out. The other thing is ecosystem providers, like partners, like all of us could also play a role in that, right? So you could have the hyperscaler, the service provider who has the real estate. You could have, network providers. We come out with different business models, and we create that kind of ecosystem. You have the application vendor. So that, all of us could play a role in that. Sure.
Yeah, I just had some thoughts, and it kind of goes a little bit on from what Prakash was saying. I mean, from our point of view, and with some of the companies we work with, we're working with some startups who are playing in the disaggregation and the GPU clustering space. I mean, you think about it today, a small, medium enterprise, if they want to do AI, they pretty much rely on talking to hyperscalers using AI as a service or one of the big OEMs. So there is a market out there for companies that can come up with these innovative networks that can do smaller scale stuff. And we're working with a couple of customers that do exactly that. They're startups, they're well funded, but they are there, and they're creating sort of disaggregation structures. They're creating GPU clustering services. So they're creating software, PCI cards that can be used with other people's technologies. And I see that happening because this is, that's what's going to drive the growth for the smaller companies. It's not just always going to be reliant on just the hyperscalers to provide those services. Some customers are going to want to do it themselves. So it's unbundling that bit and allowing you to do it yourselves. And as I say, we work with a couple of smaller startups that are doing exactly that. So there's a little bit, but I think the market's coming to it right now.
Sure. Thank you so much. So thank you so much. We reached to the end of the session, but before getting into the Q&A, although I mentioned in the earlier question that I haven't come across any startup doing worthwhile innovation, but let me tell you, there is one startup, and which I'm kind of promoting now. On behalf of the government of UP, we have brought one startup which is into the e-governance and telecommunication space. The stall is near Vodafone and CDEC, hall number 5. That's where an intelligent village concept has come up. And there are 4-5 startups which are partnering to create this particular solution. It's AI-enabled platform. And there is one startup which is working on a device called sort of micro-edge device. I'm not sure whether it can be dubbed as data center, but it's a micro-edge device because they feel that once the village has been digitized, this intelligent village will be creating a lot of data by virtue of having multiple kind of IoTs and by usage of G2C services. All of this data doesn't need to go and hit a cloud or maybe a data center far away in Delhi or Noida. So therefore, this entire data will be hosted there on a micro edge device, which will be probably 10 TB storage and some processing capability. For example, you got public surveillance feed of your coming out of your CCTV, and that is hosted there. And you could process the data, democratically. You have given the access to the village panchayat level, and the data is being hosted there, being utilized there, and only the relevant part of the data goes to probably the government state data center or wherever it's required. So that is a small bit of innovation which I could see from this startup. Now, coming back to the session, now I'm opening it up for the Q&A. If any one of you have any questions from any of the panelists, I'd be very happy to. Yes, please. If we can have the mic, Arnab, if you can have the mic in the audience, please. Yeah.
So I have a question for Mr. Abhishek Tiwari. Actually, you told that you have been part of some telecom policy formulation. So I'm posing you a situation, a challenge that is like recently India came up with the IT regulation guidelines, that is the Intermediary and Digital Media Ethics Code guidelines, which which emphasized on data localization. That is, the data centers are to be physically present inside India so that they are legally liable for everything. But there is also a contradictory here that most of the tech companies which manage the data are reluctant to do that because of the geopolitics and the policies and lack of infrastructure. So how do you, as a policy formulator, how do you manage the situation? So.
No, I think data localization is the way to go, and that is something which everyone has to accept the day it is notified by the cabinet and the parliament. But I think as of now, the policy is up for the JPC where it is being reviewed, and we all are waiting for the day, because once the data localization policy comes and some stringent regulations like GDPR and all that comes into India, only then the industry is truly going to flourish. Because regulation is a very interesting topic. Regulation is like a friction. If you don't have the friction, then the life will not go on. So it's a good friction to have. And with regulation, you see the industry flourishing in a completely different way. It is always not negative in the sense that it dampens the growth of the industry, but sometimes it helps in flourishing as well. So we are desperately waiting for that regulation to come in.
I'm sorry to interrupt, but actually, as you told that India produces 20% of the data globally, and 80% of them are being managed by foreign companies.
Correct.
But if they are going to be reluctant in this, how are you going to convince them? Because if they are being reluctant, it is a major loss for India. So how are you going to, as a policy formulator, how are you going to manage that?
See, reluctance does not have any play when the regulation comes around. So when government mandates it that you have to store the data, and you can say that not every single piece of data has to be stored within the country. There is a non-negotiable data. For example, the fintech data is already being stored. You can't store it outside. But when you are looking at social media and all other data, so it will be a gradual process. I don't see a day where you are just going to plug out completely that from tomorrow onwards, or maybe tonight at 00 onwards, you will not be able to save any data whatsoever outside the national boundaries. It is going to be a gradual process, and it will be a smooth process and very convenient for all the stakeholders involved in it.
So what is the main, if I see that a company suppose migrates 50% of its assets or servers to cloud, the main hamper is either the cloud cost which are increasing or the migration techniques which are difficult. So what is the main thing that stops 100% migration to cloud and it takes time?
So your question is rather if you're moving to the cloud, right? And you're saying that why not move 100%? Why only move 50% as such, right? So cloud, it's now today you have two schools of thought, right? I mean, the cloud wave is not new. It's more than a decade right now. And there's also the thought of repatriation, which is you're on the cloud, you've moved lock, stock and barrel, and then you figured out that that's not the best destination. So let me move on-prem. So the thought process in most of the customers that I've spoken to, the fact is that cloud is not the end or be all as a destination. The point is you want to be able to create different destination sources, be it on-prem, be it on the cloud. Different hyperscalers might offer different services. Like for example, if you're using your communications, your emails and etc., you might have a particular choice of vendor ecosystem that is there. Probably you're looking at Gen AI and etc. There would be some other workload where it's better off somewhere else. So you're building that capability to be able to move the workloads across seamless way. At the same time, like what Abhishek was mentioning, data gravity, data localization is also important, especially if you come from a heavily regulated industry like the fintechs and etc. You don't want that whole data mobility to happen in a seamless fashion, right? When I say seamless fashion, because governance, security takes precedence over, the mobility as such. But having said that, what really today is happening is you have the cloud economics that comes in. Whether you're doing it on-prem or you're doing it on the cloud, you want to understand what is the cost implication of running this, where you want to run it, what is the performance that it's catering to, and you want to look at various parameters, KPI parameters, and decide the destination. So there's no now, that's why I told in the beginning, there's the whole idea of borderless data center. Everything is not concentrated in one destination. You want to adopt that multi-cloud, you want to, and especially, ecosystems like Red Hat makes it seamless, like, the whole containerization comes in now. So your mobility comes in now. So that is the more important aspect. Are you able to have mobility, simplicity, automation at your core, that you're able to move these destinations based upon the KPIs that you've set in, and more importantly on the cost factor, the total cost of ownership that is there. So it's just not about moving 50 or 100, but the capability to move. At the same time, you're modernizing legacy applications as well. Yeah.
I think, good question as to why not 100%. It's all about efficiency and scale. You need to deliberate as to what's right for you, whether it's a hybrid one or a multi-cloud strategy. Not every workload is necessarily for cloud. You have a cloud, you have an application which is, where you know that the users are fluctuating on a particular day. You don't know what the kind of compute power and other things you need. You look at cloud, and there might be workloads where it is a finite number of users, finite workloads. Maybe look at doing it on premise. So it's not, as he said, it's not the end state. It's all about using the right strategy, making sure it's hybrid in nature or multi-cloud in nature.
Good evening to all the esteemed panelists. I am Abhishek, Senior General Manager from MP State Data Center. I am in charge for the State Data Center of Madhya Pradesh. So my question is intended towards a very basic, how do we measure the capacity of data center? It's in terms of megawatt, it's in terms of the consumption of electricity. So I have been thinking, and I want to pose this to all the esteemed panelists also. Shouldn't this be changed? We don't measure capacity of something by its capacity to consume something, by its capacity to produce what it is intended to. So shouldn't it be hosting capacity instead of electricity consumption? That's my question.
Well, that's actually a good point. So what you're saying is the measured index, what we measure a data center capacity, it should be on actual revenue generating capacity.
Not revenue generating in terms of hosting. The purpose of
Yeah, that's what. So the infrastructure which will help a data center basically host workloads.
So to put my points simply, we don't measure the capacity of a car by its ability to consume petrol. We measure it in terms of its speed or its average, that is kilometer per unit fuel consumed. So in the similar fashion, we should measure data centers.
That goes back to the point which I highlighted earlier, right? So that power usage effectiveness of a data center becomes very critical, right? So it should ideally be one, but it's not really one. And people are targeting it to be around 1.3, 1.4.
Yes.
Yeah.
So that PUE is, it is the ratio for the IT load as
That's
well,
right.
non-IT load.
Yeah.
So that is fine. So that it's efficiency of the power, whichever power we are using. But in absolute sense, if we refer to some particular data center, 1 megawatt or 5 megawatt. If it is a hyperscaler, it goes to gigawatts also. So shouldn't it be in terms of core? This is 5,000 core or 10,000 cores of data center, or you can define some other units also with a packet. Core with RAM, with storage, with licenses, with and so on.
Okay, so the compute capacity or the
Yes.
storage capacity.
Yes.
Well, this is an industry norm, but yeah, it's a good point. It's an industry norm, the power, it's basically measured with the power capacity that it has been built. But I don't know, maybe Prakash, you want to answer on?
I really, not something that I would be able to, but yeah, maybe Abhishek, I don't know, maybe we can maybe take it. You want?
I think first of all, I agree. It's an industry thing. At the end of the day, it's like when you go at the supermarket and you're buying bread, right? There is the price of the bread. What are you buying when you basically go to a colo? You are buying space and power. And therefore, that's why they are charging you on the. It's not the fact that you are consuming, but it's the fact that you are buying actually that power capacity. It's not what are you producing. No, you then buy space and power, you will produce something. But that's more relevant for your organization. But the data center, player that is selling you that space is selling you space and power. And they want to be charged because of that.
I think I have been asked this question umpteen number of times, and I can safely say that I have never been able to convincingly answer anyone. But I will try once again today. I will take the same example what you took for a car. Car is also measured in horsepower or cc. Okay. Why is that? Because if you look at the fuel consumption, I'm a very bad driver. I do rash driving, and therefore my mileage is never as great as probably when my brother drives. He drives so smoothly, and I love sitting in that car when he's driving. Also, my mileage is much more improved. So there are multiple factors. If you're going on a highway, if you are going through a busy market, if you are a bad driver, good driver, if you're in a good mood, bad mood, everything plays a very important factor in terms of what consumption per liter you are getting. Similarly, for the data center, if you look at how do you measure, because sometimes you are storing data, sometimes you are computing, and the interchange is happening. You don't know on what basis you are going to look at. So, because most of this question most of the time is coming as if that we are only going to store data. So how many bytes of data you are going to store? But then you are completely ignoring the compute, which is very important factor. And it is so dynamic in a data center that it will be, I don't think anybody has come up with that kind of complex formula to assess the compute, the storage, everything together, and then finally come to a measurement unit, which could be a fantastic unit which can be bought by everyone. So, which is why I think it is ease of calculation, and also because it is, data center industry's power guzzler. So when you look at most of your decisions of investing into any state, again, I'm taking, from a government aspect, that when you are deciding a location, that which state do you go, which location do you go, availability of power is such an important factor, that how much of storage you are going to have, how many servers will you deploy, all of this is non-existent. Do I have the power availability? What is the rate of power available? And how freely I can have the access. For example, when we were looking at UP, I can tell you that was the most painful discussion with the power department, that how do we put out those clauses which are impacting the power. And finally we were told that we, as UP, we don't generate any power, so please do not give any subsidies. And we did not give. We figured out some other ways in terms of wheeling charges, transmission charges, so many other things. But power subsidy in terms of the tariff rate was not given. And that is the major concern for an investor when he's deciding to invest in a state. Right? So, which is why, again, I'm trying to answer you. I don't know how much will you buy it and whether you will be convinced, but that is the closest answer I can come up to. Yeah. Thank you so much.
Thank you, Abhishek. I think due to the paucity of time, I think it's time to wrap up. I would request everyone to take your questions offline, please, with the panelists. And I would just request my team members if they could present the mementos.
Thank you so much, Arnab. So thank you so much, all the panelists, and it was fantastic session. I think we shot up some time, but it was so engaging that I couldn't stop myself. Thank you.